Our clients should care about quality if their product is critical. We take extreme care in knowing the details about production so that they don't have to. We're able to lift that task off of their shoulders. We're taking ownership over the quality side of our production.
So the hope is that there's learning lessons from this that you can apply to be able to make informed decisions about how you leverage additive, and whether you're working with DI Labs, you're doing it yourself, or you're working with others, it has the ability to make a real impact.
So how do we manage the difference between promoting quality and ensuring quality, which is really enacting to ensure quality? Well, I think the most important step is working with our clients to understand what their quality expectations are. Because ensuring or promoting a blanket quality statement is not aligned always with clients' expectations. So we work diligently with our clients, our engineering teams, our clients' engineering teams, to know what's the application, what are they looking to solve with this product, and we put in place quality steps either to ensure it or to ensure that they don't get any defective parts that they don't want. And that's our promise that we make internally and to our clients. We need to know, and then once we know, we can act.
Yeah, so on the incoming project side, there's two extremes. There's the model file that's accompanied by a print that's very well defined with tolerances and dimensions. And then there's a model file that comes without a print. And there's cases where that model file with that print, the print actually isn't critical to the quality of the part. It might just be a prototype that I just need to test fit the prototype. And there's other cases where that model is in fact critical, and it should have a print accompanied with it for critical to quality dimensions. And so on the front end, our job is to understand what the intent is so that we can help guide through the definition of those quality steps. In every project, every single project that we manage and that we produce parts for is reviewed by an individual. So we don't have any projects that go through an auto quoting system. And that first and foremost is probably the most critical. It's just understanding what the expectations are. And it's complicated because it's not always super clear to our clients what they should be expecting, because in some cases, it's the first time the part will be used. But that's just on the front end, right? And then we've got the process control throughout the production. We've talked about designing builds, which is a critical aspect of quality. But then we have this CMM process that we've implemented for the analysis and assessment of as-built parts against designs.
So we're using the CMM today to look at our outputs and then recalibrate our inputs. So we're continuing to improve, build data sets so that as we're working on programs, we can ensure that the design product on the front end is going to meet the output on the back end. Sometimes that requires model changes. Sometimes that requires us to manage the design build a little bit differently so that we can meet those quality requirements. We tend to work with each of our clients through that stage so we can understand where are we allowed to play. Is there anything off limit? Is this a locked part that we're not allowed to have a new rev on? Do we have to manage all on the digital side for us? Or is this something where we can talk through a redesign? Let's figure out how we can modify your part a little bit to save you money on your production and also improve the quality output. If we get into a stage where we have to live with a design that's injection molding, based on injection molding or based on CNC, and it's not meeting all the details that we need to have consistent output, that defect rate essentially is a cost that we incur, and it's attributed on the sales price. So it's our goal to improve those parts to decrease the defect rate, which ultimately saves our clients, money on that program. That's our objective.
It's even more complicated than that because the platform that the part is being produced on may vary. It may have a fundamental difference in output dimensions versus another platform. Even on a powder bed system, we may have two powder bed systems that look the same, different model numbers, and they produce parts with different dimensions. So understanding what the history is on the parts so that we can put those parts down the right platform, produce them on the right platform, and then understand what the variation is with a CMM so that we can fine-tune the model if needed. What is 3D scanning CMM? A CMM is well known in the industry, and it's a coordinate measuring machine. And so well known that I know it right that easy. And it's typically a probe that's on an arm. So you've got an arm similar to the arm that's here that's holding the microphone, and on the end of this arm is a probe. And this thing has servos in it, essentially. They're not servos, they're...
It's a position measurement.
Yeah.
It essentially has position measurement sensors in it.
It's measuring the X, Y, and Z, and
That's right.
it's triangulating to that particular point. So you'll measure a part in a particular point and then measure another part, or another point on that part, and you map it. Having done surveying before, it's like surveying, but you're doing it on the part with triangulation. And that's a very precise way to measure parts and validate them for quality. 3D scanning is also a tool that's used for scanning parts and getting 3D models of them. However, most 3D scanners, almost all 3D scanners, don't have the precision or the resolution to be used at a metrology level, which is basically at a CMM level. So we've invested in a 3D scanning CMM that allows us to do full-scale geometric measurements. We can do a deviation analysis of the actual printed part to the design geometry. And that was a significant investment. We don't use that for product development. That is essentially solely used for production quality. And we do use it for some R&D and production. We've been doing some analysis to understand dimensional variations in different parts of the builds of different machines with different materials, so that we can understand, in the front end, be more proactive with adjusting for and understanding tolerances within those machines. But it's almost like we're taking we've added on this scientific component to our production analysis so that we can understand these variabilities and then provide better direction and guidance on the front end to our clients.
Our clients should care about quality if their product is critical. And to us, ensuring quality means that we're tracing the steps throughout the manufacturing process. We're checking for meeting their quality requirements before shipment. And we take an extreme care in knowing the details about production so that they don't have to. So that's what ensuring quality means to us, and our clients who experience that appreciate it because we're able to lift that task off of their shoulders. We're taking ownership over the quality side of our production.
For sure. And the other area where they should care, I'll define the critical applications a little bit more, especially where customers are producing components that are going into assemblies, and those components are 3D printed. One or two, or maybe all of them are 3D printed, especially in mechanical applications where all those components need to fit together and work consistently. That's where quality at the dimensional and 3D scanning CMM level is critical. For simple enclosures, I would argue it's still critical to have a controlled process to limit tolerance variation, but it's absolutely critical in those components that are multiple components working together in a system, and fitment and function is critical.
And we're leveraging the CMM today, but we're not putting every part through the CMM.
Heavens no.
No, it would be... It'd just be irresponsible to do that in every case. But what we are doing is we're tracking the critical parts as necessary. We're using it for manufacturing development, and what that does is that improves quality in all products that we make, because we understand to a greater level of detail what variables are causing impact.